Okay, so let's move on to blocked billboard 2. Yeah, I think blocked billboard 1 is in the notes section over here. Yep, it's here, and you can see how they solved it. And I think it's similar, but a bit harder. So let's look at block billboard 2. So Bessie the cow used to have such a nice view from her barn, where she could see two billboards that showed cow feed. Unfortunately, one of these billboards has recently been updated, so now it shows lawnmowers, which she hates because lawnmowers cut the grass that she loves. So, fortunately, the remaining cow feed billboard is situated in front of the lawnmower billboard, potentially obscuring it. Bessie is determined to remove the offensive billboard completely from her view and hatches a plan. She plans to steal a rectangular tarp from the barn and sneak it out late at night to cover the remaining portion of the lawnmower billboard so that she can no longer see any part of it. Given the location and the two billboards, please help Bessie compute the minimum area of the tarp she will need. Since the only tarps available are rectangular, Bessie observes she may conceivably need a tarp whose area is slightly larger than the exposed area of the lawnmower billboard. The tarp may only be placed such that its sides are parallel to those of other billboards. So in the input we're given x1, y1, x2, y2, so which is the lower left and the upper right corners of a billboard. And the first rectangle is going to be the lawnmower billboard, which we want to obscure, and the second billboard is going to be the billboard of the remaining cow feed billboard, which is in front of the first billboard. So we're trying to find the minimum area of the tarp that Bessie needs to use to cover part of the lawnmower billboard so that it becomes completely obscured. Okay, so let's think about this. Oops. So we have two billboards. This is the cow feed billboard, and then the one we want to remove, I'll highlight in red. Maybe this billboard, there's no overlap whatsoever, so she needs to get a tarp of the entire area of the lawnmower billboard. Or there could be some slight overlap, but I think there are two types of slight overlaps. One is something like this, where even though there is an overlap, you would to cover this portion, you would need to cover the entire billboard. Whoops! What I meant to say is that this portion we know is covered by the billboard in front, so we can't see this, but we're able to see this everything else. We're still able to see all of this. So to cover this, we'll still need a tarp that goes over everything, because since it's a rectangle, this let's do a tarp like this would not cover everything. A tarp like this wouldn't cover everything, so we need a tarp to fully cover this. So even though there exists some overlap, we still need the tarp of the entire width and height of the lawn of this red lawnmower billboard. But on the other hand, if the lawnmower billboard was boom, say something like this, right? Actually, let's come back to this case for a second. If the lawnmower billboard was something like this, then we know that this section is fully covered by the remaining cow feed billboard. So the only tarp area we would need is one covering this 3x3 square. So the answer here would just be 9, because the current cow feed billboard covers a rectangular portion of the cow feed billboard, and this rectangular portion is the same as the entire height. And then there could also be a case where the cow feed billboard is fully behind, which I think is a possibility, even though that makes no sense. But then in this case, we know that the answer would be 0, because the billboard is hiding this cow feed already. And now the final case, I think, is going to be something like this. Now over here, we see that Okay, even though we do cover a rectangular portion here, we still need to use a tarp that covers this entire thing, because there's no other smaller area tarp that would cover this entire area. So the key observation is we need to see how many corners of the rectangular uh, cow feed billboard is covered. So here we see none of the corners are covered, so the area is going to be the full area of this tarp. Now if you go back to some previous examples where if you look at the rectangle inside, since all four of its corners are covered by the remaining cow feed billboard, the answer is just 0 because it's fully covered, because all the corners are inside the larger cow feed one. Now if you look at this case, actually we see that 2 of its corners are covered, and if 2 of its corners are covered, that means that we can remove a partial area, so we can remove the intersection of both the billboards from the total area of the red tarp, which again is the lawnmower billboard. And this is even true if you look at something a bit smaller. If you look at something like this, we see 2 of its corners are within the billboard that Bessie wants to see. So then we know that we won't be able to see this. So what we're left is with a rectangular portion of a smaller area. So we can use a smaller rectangular tarp. So yeah, and the next thing to observe is there's no way. So if we have the red billboard that we're trying to cover, if we overlap any sort of other rectangle on this, we either cover none of the corners, 2 of the corners, or 0, 1, 2, or 4 of the corners, right? So if they're completely, if these 2 rectangles are separate, then we basically highlight none of the corners. If this is how we highlight 1 of the corners. Whoops. This is how we highlight 2 of the corners. So here and here would be covered. Highlight all would be like this because they're all inside. And then for 3, using a rectangle, it's impossible to highlight 3, right? Because to highlight 3, it would be something like this, but we know that the rectangulars are parallel to the x and y axis, so this can never be the case. So yeah, again, so the key observation is how many corners do we overlap of the lawnmower rectangle. So if there's 0 corners, that means there's no overlap, which implies we output the full area. If there's 1 corner, as we said, if there's 1 corner overlap like this, it doesn't matter because the smallest rectangle that can still cover it would be the full area of the lawnmower billboard. So we still need the full area of the lawnmower billboard. And now for 2 corners, well, we saw that if exactly 2 corners are covered, oh, that's a bad rectangle. Something like this. And if these 2 corners are covered, then we know it's simply the original area minus the intersection. So it's going to be full area minus the intersection. So we call it intersect. 4, we know 3 is impossible. And then finally 5, if all 4 corners are inside, it means it's 0 because 1 rectangle is inside the other. So yeah, it's just making these observations, and the key thing of this problem is to notice we have to focus on the corners, because I think that's the fastest and the best solution to this problem. So yeah, first let's go here. So I'll use the rectangle snippet, and the key thing that I've added is this portion for intersection. So how do we calculate the intersection? Essentially, let's just look here. We have one rectangle here, have another rectangle here. We want to get this rectangle. So we want the rightmost left point. So we see, so we're given, I'll just highlight in pink the points we're given. This point, this point, this point, this point. So if we look at the bottom left points that we're given, so this one and this one, we want the rightmost of that because that will be the start of the intersection, right? And then we also want the leftmost right point. So the top right will give you the right points, and this will be the leftmost right point. So that gives you the range from here to here. So we know the width of the intersection of the rectangle. And the same thing for height. We want the lowest top point. So if this is a top right point, these two, the lowest of those two would be here. And then we want the highest bottom point. And these are the bottom left points. And this is the highest one. So now we know the height. Because, yeah, the intersection means that there is an overlap between both rectangles. So if we get the rightmost left point, the leftmost right point, the lowest high point, and the highest low point, then we know that all these 4 points are going to be in between. There's going to be overlap between both rectangles for sure, and therefore this is why here we do minimum of a dot x2 b dot x2, which is going to be the minimum of the rightmost point and the maximum of the leftmost point, and the minimum of the highest point and the maximum of the lowest point. And we know for sure that the lowest point is going to be higher than the max point. And if that is not the case, it means that there is no overlap. So this would be a number that's negative. And if that's the case, we just want to set the max as 0. So then we know the area is going to be 0 for sure. So yeah, let's read it in. So we're given 2 rectangles. So one is the lawnmower one, and one is the grass field one. And so then we read in lawnmower.x1, lawnmower.y1, lawnmower.x2, and lawnmower.y2. I think it's this. Same thing, except I change this to the grass field. Okay, now we've read in all our inputs. And now the first thing I'm going to say is how many corner overlap is there. So we want to check how many corners of the lawnmower billboard are covered. So let's make a function called covered. Oops, caps lock. And we'll give it in. So there are 4 corners, so we need to pass in all 4 corners, and each corner will have a x and a y. And then we'll also pass it the rectangle for the grass field. Now for a point to be covered, right? So how do we know if, oops, let's take a bit of this away. Okay, so how do we know that this rectangle, so let's say we're given this point, how do we know that this is covered by the grass field? It's covered if it's within the grass field. Within means it's either inside or on. So the way we check that is whether this x is within the boundaries of the x that we know for this rectangle, and the y point for this is within the boundaries of the y that we know. So essentially we're saying that so we want it to be a Boolean, doesn't really matter, and we want it to return true if it's covered. So if gf.x1 is less than or equal to is less than, so if x is greater than or equal to the leftmost point of the grass feed billboard, and x is less than or equal to gf.x2, which means it's within the left and right boundary, it means this x coordinate is within the possible x coordinates in the grass feed billboard. Now we do the same thing for y, and gf.y1 is less than or equal to y, and gf dot and y is less than or equal to gf.y2. If that's the case, we return true, otherwise we return 0. So now let's have an integer. Let's say corners covered, so initially 0, then we need to so it would be corners covered plus equal of the function covered, and we give it the corner and the rectangle gf. So there'll be 4 corners. So the first one is obviously going to be lm.x1, lm.x2. The next one is going to be, it's y1. The next one would be, the next corner, which is going to be the top right corner, would be x2, y2. Now we want the top left corner, which is going to be x1, y2, and we want the bottom right corner, which is going to be x2, y1. So now it's just going based off this. If corners covered equals 0 or equals 1, we want the full area. So if it's less than or equal to 1, we just output the area. Do we have a function for that? Yeah, so it'd just be the lawnmower.area if the corners covered is 2, then we can just see out lm.area minus the intersection of lm and gf. And then if the corner covered equals 4, then we just see out 0, because the cross feed is fully covering the lawnmower billboard. And let's see if this works. Okay, so I think okay, so the example given shows a case where one corner is covered. We can just check this. If I just do debug corners covered. Yep. And now if it's fully covered, would be, if you're given the same thing twice, this should be 0. Good. Oh, I don't know. Copy this last line again. And now we need to check where there's no overlap whatsoever. So we can do minus 100, and I think that and 0. There we go. There's no overlap here, and the answer is still 15. Good. And now the last case is if there's an overlap of 2. So you want this to be 1 and 6. Is this correct? So 1164. So we give in, whoops. Did it make this white again? go here. We want 1, 1, and then 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4. So this is the first rectangle. And then the next rectangle is 2, 1, 7, 4. So it'll be 2, 1, then 3, 4, 5, 6, 7, 4. It's going to be like this, and the answer is indeed 3, which is what we want. So this should work. Okay, the name is Billboard. Okay. So, oops, do this, this. I think they should be fine. USACO, bronze, Billboard 2, open. And voila.